Hi, welcome to our fourth lesson in our fifth grade unit on matter. And this lesson is going to begin a group of lessons that all focus on one problem. Now, a problem is a really specific word. I'm not just choosing a random word. A problem is something that you need to solve or an improvement that you can make, and problems are the world of engineers. So engineers solve problems, and another word we might have for a problem is a design task or a design challenge. So we are looking at activity page 3.1 here, and this is titled, the title for this page is Identifying Matter. Now I'm going to go ahead and cross out that title because that's really related a little bit to what we're talking about, which is physical properties of material, but it's really not what we're doing here. Scientists try to identify matter based on their physical properties. What we're really doing is we are choosing the best material. So I'm going to give this a new title, which is Choosing Materials. Because as an engineer, when you have to solve design problems, one of the things that you need to do is choose the best material for the job. All right, so I have a story to tell you about for this particular lesson, and that story is the story of a home that I lived in earlier in my life. This home was an apartment building, and in this apartment building, we were preparing to move out of the apartment. And while we had lived in the apartment, we went around the apartment and we hung pictures and we hung pieces of decoration on the wall. And because we did that, we left screw holes and nail holes. And before we moved out of the apartment, one of the things that we had to do was patch all of these screw holes and nail holes so that we could get our money back for our deposit. Now, we needed to find a way to do this quickly, and we didn't want to spend a lot of money. And we also really wanted to make the holes so you couldn't really see them, so that maybe the whole apartment wouldn't have to be repainted, which would have cost a little bit more. So we started thinking about our design problem. Our design problem was, how can we fill the holes in the wall for the least amount of money with materials that we already have on hand and that will match the wall. So we started to look through our apartment. And since we were only patching small little holes, what we found is our solution was just some white toothpaste. And so we just took little bits of toothpaste and stuck them on our fingertip and filled the holes with a little bit of toothpaste, and the holes disappeared. You couldn't see them any longer. And that story I thought of because I've kind of been excited about this design challenge and this activity. So in this design challenge, you are going to choose the best material you can come up with to try to repair a hole in a wall. So we're going to transition over, and Miss Wynn is going to share a reading with you. And then after she shares the reading, we'll actually end today's lesson, and we will resume tomorrow by looking at the observation sheet. So the observation is going to give us the investigation that we do is going to give us a whole large number of materials. And we're going to study the materials and try to determine which of these materials would be the best to fill the holes in our walls. Based on what I've told you so far, go ahead and look at activity page 3.1. And on activity page 3.1, try to figure out what our design problem is, review the list or review the physical properties that we've talked about so far, and then figure out, of those physical properties, which ones would we need to pay attention to in order to figure out how to solve our design problem. And if you get those things recorded, when we come back in tomorrow's lesson, we will look at the different stations to help us gather information about the properties that we determine are important. All right, thank you, Ms. Wynn. You can go ahead and take over reading, and to everyone else, I look forward to seeing you in tomorrow's lesson when we get to work with this design challenge.
Thanks, Brian. Hi, this is Ms. Swin, and I will be doing the second part of our lesson today. Our focus question, our big question is, how can I use properties as evidence to identify matter? Last time we talked about matter having different properties, such as color, hardness, magnetism, and electrical conductivity. Okay. So today we're going to think about how we can use those properties to identify different matter. Today's learning objectives are investigate and record the properties of different samples of matter, use evidence from observations and measurements to support a scientific argument, and identify examples as particular types of matter based on our properties. Now, this lesson is several days long, so we will be reading about the background information that will enable us today to be able to achieve these objectives when you have some more lab work with Brian. Here's our reader, Investigating Matter. Today we're reading Chapter 2, Applying Properties of Matter. Applying Properties of Matter. Imagine your school has to replace the chains on the playground swings. The school asks the students to act as engineers and come up with a solution to this problem. An engineer is a person who designs and creates things to solve real-world problems. When trying to solve a problem, it helps to use the design process. The design process is a method people use to find and develop a solution to a problem. There's our big question in this chapter. So if I'm trying to solve a problem, like an engineer, I need to use the design process. And we use the design process, it says here, to develop a solution to a problem. The solution to a problem can be a physical object, or it can be a procedure for doing things a certain way. And a procedure is just a series of steps. For example, you may have a procedure at your school on what to do if there's a fire drill, or there's a procedure for how to turn in your homework with your teacher, or you might have a procedure when you come home from school. Then we have our vocabulary box down here. It reminds us that the design process is just a plan that is used to find and develop solutions to a problem. And here's the other part of our definition: solution, a way to solve a problem. To solve a problem, it starts by evaluating solutions that were used by others. For example, chains used in the past had some positive properties and negative properties for use on a swing. Your design can improve on the existing solution or be a completely different solution that solves the same problem. So before we solve any kind of problem, we need to think about or evaluate how other people have already solved the problem. For example, here's the swing. This is an old swing. You can see possibly that there's some rust on this. So we want to think about, why did they make the swing this way if it's going to rust? They probably had a reason for that. But the point of design is that you also want to think about improving the existing solution. Now, this swing, we know it works, but there might be a way to make it even better for the boys and girls and grown-ups who decide to use the swing at a park or at your school. So it might look very similar to this, or you might think of a completely different way to make a swing. The same idea applies for other things that you might design and build. Think about why, it says here in my caption, why would the school want to replace these chains? And so one reason I said is that it got rusty. when I look at the chains, you see these little holes? I think they might be a little bit dangerous for little boys and girls who might get their fingers stuck in there. The other thing I think about as far as Tennessee goes in the summer, I know you guys are not really in school in the summer, but the parks still have swings. And if these are all metal, it makes me concerned that it might be too hot to use, because we wouldn't want anyone's hands to get burned. So here we have something it's functional, it works, but we might think of some better solutions. All right, so let's take a look at the design process. And so how does the design process work? Well, first, we have to define the problem. The first step in the design process is to define the problem. In our case, we need to replace the chain on the swing. You have to consider criteria, the standards by which something is judged. Think of it as when you have a project for school, your teachers probably give you their expectations, like your assignment needs to be about certain subjects, you have to answer certain questions, you might have to include visuals. So those are different kinds of criteria for an assignment. Same thing here happens when you're designing. You need to consider how are you going to judge, whether what you created is the best. When we consider what properties the chain should have, we are establishing criteria. You also have to consider constraints, which are limits on the design process. So we have this other word, constraints, which are limits. So there might be things that you don't have. For example, with homework or an assignment, some of the constraints might be that you don't have as much time as you would like to work on that project. Or perhaps you don't have the materials you need and you need to go get them or replace the materials. Next thing you want to do is plan a solution. The next step is to plan a solution. Think about why the chain needed to be replaced. What part of your solution will address the problem? Be sure to consider the criteria and constraints as you plan a solution. So both criteria and constraints are really important. So when we think about the chain, maybe it was rusty. And so we'd have to replace that because we don't want anyone playing on the swing if it's rusty. So this is very, very important, this last sentence. So I've underlined it here. You have to consider both the criteria and the constraints. Then you have to make a model. The next step is to make a model. The model should be similar to real life so you can test your solution under similar circumstances. What properties would your solution to the rusty chain have? What features should your model have to replicate the real world in order to test your solution fairly? So it says here, whatever model you make, it has to be similar to real life. So you don't just want to test it in your bedroom or your classroom or your dining room if you're building things there. You want to have your model be tested wherever it would normally be used. So for a swing, we want to test it outside because you don't have a swing inside your house or the playground, right? So we want to make sure that that model works, or at least we can test it in that environment. Test the model. The next step of the process is to test your model. When you test your model, you should test it in similar conditions to show how your solution will be used in real life. And what type of conditions would you need to test your solution for a rusty chain? What would be a good test of your solution's properties? So again, with the make a model, we want it to look like how it would look out there in its real circumstances or a real environment. And then we also want to make sure that we test it in similar conditions. What would be a good test of your solution's properties? Okay, so this is where we have to consider, what do we know about the material's properties, so we can test to see if it stands up to the criteria, if it meets our criteria. Evaluate and redesign. The last step of the process is to evaluate the design. Does it meet the criteria and constraints that you set when you defined the problem? Again, we have criteria and constraints. We need to meet both of them. Even more important, does your solution work? Some solutions will work without meeting some or all of the criteria. Some solutions will work without meeting some or all of their criteria and constraints. So my solution, it says here, obviously we have to make sure it works, but it also says that my solution might even work even if it's not completely perfect in terms of checking all the boxes for what my criteria and constraints are. You may also find that there were criteria and constraints that were missed at the start of the design process. Some great inventions have been the result of errors or mistakes in the design process. Oh, isn't that interesting? That mistakes are fine, because that helps us to learn that we forgot that, or we didn't realize that there were certain criteria and constraints that existed. And even here, that we might have some things even that we use now that were even mistakes. So I might want to go do some research about how different things were invented and which of them were just mistakes. And they were trying to invent or produce one thing, but they ended up making something completely different. This is also the stage to consider ways to redesign your solution based on testing and based on other criteria and constraints you have uncovered. If your testing reveals that your solution won't work, you should test again and consider ways to redesign your solution. So this is important. We want to make sure that we don't quit just because it doesn't work. We just have to try something different. And here's a graphic that reviews the different steps. Now, I know in the text, it talked about having a first and a next and a last, but this picture, this diagram shows me, in fact, the design process is not, it doesn't have a beginning and an end necessarily. It actually goes in a circle. You want to have a problem, you plan the solution or a solution, you make a model of it, you test the model, you evaluate and redesign when necessary, okay? And then you go back and say, oh, well, it's kind of still a problem, so you keep going. And in fact, this part here, evaluate and redesign and plan a solution, if it didn't work or you think there might be better ways, go through the cycle again. You can go as many times as possible. Now this section says selecting materials based on properties. Remember last time we talked about the different properties of matter. So we want to think about those characteristics of material so that we can make some good choices. Apply what you have learned to consider good materials to replace the chain on the swing. First, think about the properties, criteria, and constraints of using the chain. Okay, so the properties of the chain. So things we already know about the chain that exists on the swing is that it's hard. Okay, the actual chain is hard, but it's also flexible, because I know on those swings, at least when you link them together, you can turn them and they move, right? They're not rigid, and otherwise the swing wouldn't work. We also know that it's shiny. So as I think about redesigning or replacing the chain, what are some of my criteria that I might consider? So for a swing, I want to make sure it's strong, so it can hold everyone up. You do want it to be flexible. and easy to grip. Because the swing works, we have to hold on to it, right? So we have to make sure it's easiest for us to grip. And what are some of the constraints or the limits? Cost. Some things might cost more than other material. And we only have so much money to spend on it, on the actual product. We also want to think about the size of someone's grip. For example, who is this swing for? Is it for little children, or will it be for grown-ups as well? We want to think about how wide the material might be so that everyone who is intended to use it can use it and hold on to it. And weight. Now here I'm thinking both what's the weight of the actual material, but also maybe like the weight of the person who's riding on that swing. So once we consider those things, we now consider 3 possible solutions to replace the chain. Each possible solution has advantages and disadvantages. So when I'm doing a design process, it seems like it's saying to me that I might think about more than one way to do it. And also to evaluate what the possible advantages and what might be good about it, and disadvantages, what might be some weaknesses in this plan. Now consider, I already said that. So here's the picture of 3 different kinds of materials. Nylon rope. Let's look at nylon rope. A nylon rope we know is strong. It gets stiff in the cold. Oh, that means that's not flexible, because stiff and flexible are antonyms. It weathers well. In this case, weather means it lasts in different kinds of weather. Like it won't get ruined just because it's too sunny or too rainy or too snowy or freeze and break off. So, or it holds up to different kinds of weather. So that sounds like it could be a good choice, except for if it's too cold and it gets stiff. But then I wonder, if it's really that cold, do I still want to be outside? Depends on how cold it is, I guess. Let's look at the nylon strap. Now I notice that both of these first 2 solutions use nylon, but this first one is in the shape of a rope, and this one's more a flat strap. So the nylon strap is strong. It's hard to hold. If you think about the strap, it's skinny, it's thin, so it's probably not that comfortable to hold because it's all flat and kind of not really sharp on the ends, but not really soft either. It does not weather well. Wow, isn't that interesting that they have the same material, nylon, but the rope weathers well, but the nylon strap doesn't. I wonder why. Now we have the last possible solution, the jute rope. It says here that it's strong, it's easy to grip. Those are 2 advantages. And a disadvantage is it does not weather well. Well, when I look at all these 3 options, none of them are perfect, right? And that's okay. Let's keep thinking. How would you test each possible solution? What properties of each solution would you test for? What if none of your solutions meet all the criteria and constraints? Like in this example, none of the 3 fit all of our criteria and constraints. You would examine why each solution didn't work and apply that as you redesign and test again. In the design solution, you can continue to test and retest solutions until you come up with a solution that works. Now, the design process does require you to be a person who doesn't give up when something works or doesn't work right away. There are many ways we can solve problems. So I want you to keep that up in mind for tomorrow's lesson, where you get to do some investigations and watch some demonstrations with Brian. So you're going to look at some designing, or you're going to look at doing some designing of your own to improve things that you might be familiar with. And thanks for joining us today, and we will see you guys next time. So get ready to engage in some fun design processes next time. All right, bye guys.